All right, so you look at some pH calculations. Our pH calculations are based on how much H plus or protons we have in that solution using a logarithmic scale. You may or may not have used logs in math. Doesn't matter a whole lot. A change from 0 to 1 or 1 to 2 in a log scale is times 10 or times 100 in a normal scale. But if we do know how many protons we have in the solution, we can find the pH using a simple inverse log of it. So this negative log of that concentration of the H plus molarity will equal the pH. We can go back and forth from the H plus to the pH to figure out how strong an acid or base of the solution is we have. The log button, or the log, is a button on your calculator, as is the negative button. So see if you can try and figure this one out. I'll give you the answer in a second. What is the pH of a solution with an H plus concentration of 0.00015? Go ahead and pause it. When you think you got it, hit play and we'll find out if it matches up. Alright, you should have gotten 3.82. If you got 2.82, you probably put times 10 and didn't use E on your calculator. You might want to take a look at that. If you got negative either of those numbers, you forgot the negative when you did the button. You put in log of H plus, not negative log. Then, but wait, what if they ask you what the H plus concentration is in a solution, but they give you the pH? Uh-oh, that's not going to work. That log function will only work when you're going from concentration to pH, not vice versa. So we have to do the opposite of a log, which if you take it in math would know is 10 to that thing, to the negative of that power. So 10 to the negative pH power will get us to go back to H plus concentration. So try this one. What is the H plus concentration of a solution with a pH of 12.4? Go ahead and pause it, try and solve it, then hit play again. Alright, when you take that, and you took 10 to the negative 12.4, you should have gotten 3.98 times 10 to the negative 13th. So a really small number, not much H plus, which makes sense, because that 12.4 tells us it's a base. Bases have OH minus ions, not many H pluses. If you're told the pH of a solution is 3.4, we may also want to know what the pOH is. So the log scale of how many OH minus ions are in there, how basic it is. So we need to know for that this formula that pH plus pOH must always equal 14. This is the nice and easy math one. So using what we know that 3.4 plus pOH equals 14. So do a little bit of algebra. We'll subtract 3.4 from each side. And we'll be getting our 14 minus 3.4 equals our pOH. So our pOH is 10.6. So your turn. What's the pH of a solution if your pOH equals 4.9? Go ahead and pause it. Try and solve it. Then hit play when you think you got it. Your answer should be one of these four. Hopefully you got 9.1 because pH plus 4.9 equals 14. We need to solve for the pH, so we subtract 4.9 from each side, which gets us 9.1. We can also look at OH minus we have in the solution, like we did with H plus. So the last of our 4 pH calculations. So we know the concentration of OH minus. We can find the pOH by taking the inverse log of it. Negative log of OH minus equals pOH. Just like negative log of H plus equaled pH. Negative log of any concentration takes you to the P version of that. H plus to pH. OH minus to pOH. So, same idea, try this one then. What is the pOH of a solution that has a hydroxide ion concentration, OH minus concentration, of 0.000085? Should be one of these four. Pause it, try and solve it, see if you agree with me. Should have come out to 4.07. Hopefully that's what you got. If not, try it again or ask me or your teacher. We can also go directly from H plus to OH minus, but you don't have to. I'll show you some tricks so you can find shorter ways of doing some of these in a minute. All we need to know is that H plus concentration times OH minus concentration always equals 1.0 times 10 to the negative 14th. That's what water always breaks apart into. So, what's the H plus concentration of a solution with the OH minus concentration of 0.00055? Here are 4 options. Go ahead and pause it. Then, play again to see if you agree with my answer. Alright, when we're doing this one, we're trying to find OH minus, but it's not by itself right now. So we're going to divide this entire thing by H plus on this side, H plus on this side. It's going to take us to having OH minus ion, these brackets mean concentration, equals 1.0 times 10 to the negative 14th molarity divided by what they say our OH was. Oh, dear Lord. We're trying to solve for H plus. What am I doing? H plus will be here. We're going OH minus. OH minus. There we go. So H plus will give that divided by our OH minus concentration. So 0.00055. When we do that math, it will come out to our green answer, 1.82 times 10 to the negative 11th. Hopefully that's what you got. Then, if you think it's easier to just go through a pH polygon, I've made one for you. This is like a road map, or a treasure map maybe. They're going to give you something in the question, they're going to ask for something else. If you have this, you may want to take a screenshot or print it or have it accessible somewhere to use so you can practice. If they give you the pH, let's say they give you a pH of 3.5, and they're asking for the H plus, you just follow the arrow that's going towards that. You go, all right, what do I need to do with that arrow? Well, we need to take 10 to the negative pH of that number. So we plug 3.5 in here, do that formula, and you will get H plus. Just follow the arrow to whatever your end goal is. This is your given. This is what they're asking you to find. So you take the arrows going there. However, they could also give you a given of the POH, let's just say 10, and they want you to get to H plus again. So the find. Now note, there's no arrow going directly between POH and H plus, so we can't do this in one step. It will take more than one step on our map. We can either go this way and take 10 to the negative POH of it to get our OH minus concentration. Then once we have that, we can follow the next arrow and use this formula to go over to H plus. That would give us the answer. Or, you could also take POH and go this way, use this formula, take the 14 minus it to get you pH. And once you have pH, go back up this way, using 10 to the negative pH, get H plus. Either route will get you the same answer. As long as you follow the arrows in the right direction, this treasure map will lead you to the answer every single time. Practice question. Also, this question by Chipotle is awesome because it's gold, like the wrapper. Hell yeah. Alright, so what's the POH of a solution that has an H plus of 1.45 times 10 to the negative fifth? This is one of those two-steppers. So you might have to go back and look at your graph again, or at the pH polygon, but you can do it. Okay, so there's 2 ways we can do this. Oops. Oh, quick. Okay, so we have the H plus. H plus equals 1.45 times 10 to the negative fifth molarity. We can go from H plus to pH by taking the negative log of that to get our pH. So if we do that, negative log 1.45 e negative 5 gives us a pH of 4.84. Now that's our pH. No, pH has no units. But we don't want pH, we want POH. So we also know that 14 equals our pH plus our POH. So 14 equals 4.84 for pH plus POH. Get pOH by itself, we subtract 4.84 from each side. Gone. Then we get 14 minus that gets us our answer of 9.16. Stop doing that. Thank you. 9.16 equals your POH. That's going one way under pH polygon. However, we can do it another way, so I will show you that one as well. Our H plus hasn't changed. We can go from H plus to OH minus first by taking this equation, the 1.0 times 10 to the negative 14th, equals our H plus concentration times our OH minus concentration. Now we don't know our OH minus, but we do know our H plus. But to get OH minus by itself, we need to divide both sides by our H plus. That'll cancel. Put our bracket so it's concentration. So we've got 1.0 times 10 to the negative 14th divided by our H plus, which they gave us to be 1.45 times 10 to the negative 5th equals our OH minus concentration. That gets us 1.0 E negative 14 divided by 1.45 E negative 5 gets you 6.90 times 10 to the negative 10th equals OH minus concentration. Okay, awesome. Except the question's not asking for OH minus, it's asking for POH. So we can take the negative log of our OH minus concentration to get our POH. So negative log 6.90 times 10 to the negative 10th gets us, hey, what do you know? 9.16 for the pH. The same as the other way. Doesn't matter which way you go. Either way on the treasure map, as long as you start where they give you and you end with what they want, you will have the same answer and it'll be correct. It'll be correct and right. Alright, then the second part.